So, our wireless, as Kirill was mentioning, it's called Identify. So, the topic is about the, let's say, heavy crowded environment, which is stadium, shopping malls, training centers, conference halls, and those things. So the reality is that if you look at, in general, Wi-Fi at that environment, you have, in general, two options. You offer the Wi-Fi for the internal people, like the stuff here, which is using Wi-Fi for internal communication, or you offer that also for those people, for those fans on the stadium, for those people which are shopping in the shopping mall. And the approach for that Wi-Fi is completely different, completely different. The reason for that is something which I'll try to describe on next slides, and I would like to handle it and to address that and explain what is different. So on the picture here, you see that we are the official Wi-Fi analytics and Wi-Fi provider for NFL, and this is for the Gillette Stadium in the US, in Boston, and we have much more stadiums, so that was the first one which we have there, and that's our success, and that's our success story which I will talk about also, okay? So regarding the Wi-Fi for massive amount of people for something which we call hyperdense environment, that's completely different talking to the standard Wi-Fi. Okay, so why is hyperdense environment different? Why it is not just, you know, an access point which you put? So what is different? The first of all is the density of human bodies, so people which are there. In reality, the body itself is full of water. And water, as you know, it's something which is blocking, okay, all the electricity, or at least it is doing grounding for that. So in reality, if you do the measurement on empty stadium or empty shopping mall, and then you do the measurement on the full stadium, it's completely different. So it's 10 to 15 dBm difference. The second thing is the density of users, hyperdense environment. So if you look at the last Super Bowl which was on the NFL, which we were providing the Wi-Fi there, so that was from the 70,000 people which were on the stadium, 25% of them were connected. So that's something like over 17,000 of clients connected to the Wi-Fi in open space environment. Okay? So that's completely different if you think about the Wi-Fi and, for example, for the stadium which we have in south of Poland, where the Wi-Fi is only for internal people doing a voice over Wi-Fi over IP calls for the stuff itself. So that's completely different. And if you think about that, it's a really big challenge to handle it. And imagine that all those people can roam. So during the breaks, they can go from one place to another and still being connected. Okay? And now think about subnets, about the IP space, which you need to handle. Okay? 17,000 clients connected at the same time. So there are challenges regarding the hyperdense environment which you need to handle. Open space, that's what I mentioned already. It is not about to have coverage. Not at all. Not at all. If you want to have a coverage, you can put one access point with omnidirectional antenna and you will see the access point, so you have the signal. But imagine that you will have 17,000 clients connected to one access point. It will not work at all. Okay? So it is not about having coverage. It is about blocking the coverage. It is about choosing the right antenna, choosing the right channel scheme to be able to handle that. Okay? So if you want to have, and I will show that when I finish the slides and to do the live demo, when you would like to have a good user experience, good Wi-Fi connection, you should have access only to 1 to 3 maximum access points. Okay? All others should be very low signal to not create the noise for your access points. Okay? So this is the approach. So you need to play the game with antennas. You need to play the game with the RF propagation, radio frequency, band, and steering, and all those things. And this is a unique thing for the stadiums. You don't have second shot. One shot only. So if you advertise, hey, we have a Wi-Fi here, use it, and the user experience is bad, do you think that the user will try to connect next time? Most probably not. So you have one shot, okay? It works well or it does not work. Nothing between, okay? So if the fan does have a good experience, he will use it. If the fan does not have a good experience, you cannot advertise, hey, we increased or improved Wi-Fi, try it again. It will not work. Why our Wi-Fi? Why identify from extreme networks? We do have an experience. We do have a success customers like NFL and others, okay? So we have a team which can help to design that. Of course, we have tools to predict what will happen, to measure what is happening, and to play the antenna game. And the most important thing, we do have the product, okay? The product called Identify, and now I would like to mention several very important features which you need for such an environment. Flexibility, single SSID. I was mentioning that already on my general session, and also now there is a single SSID in the air, okay? So if you think about the, let's say, general approach like is here, look at the Wi-Fi here, you have something like 20 to 25 SSIDs in the air, all with very good signal and all present from many access points. So one access point is blocking or creating noise for another access point here, okay? Why we have so much SSIDs here, SSIDs in the air here? Why? Everyone wants to have different quality of service or different service in general, right? So you have different Wi-Fis, different SSIDs going to different VLANs, having different access control lists, having different quality of service. We don't need that. I demonstrated already on the general session. You can have one SSID, and if you have one SSID, people can be assigned to different VLAN. People or devices can be assigned with different quality of service or having different access control lists, different rights, okay? Why we should have only one SSID? What is the benefit of having one SSID only? So there are two aspects. One is social, human. If you have only one SSID, you cannot make a mistake, right? You cannot connect to the luxury guest instead of my guest. If you have one SSID only, you cannot do the mistake. Another aspect is much more technical. If you look at 6 SSIDs in the air, comparing to 3 SSIDs in the air. So what is wrong to advertise new SSID? Beacons. Beacon is a frame which is in the air going from the access point advertising, hey, here is an SSID. And there is a rule, or it's a general thing. If my device will send a probe to the air, all access points, all SSIDs in the air should answer for that probe. And what is wrong with this? Each beacon is transmitted on the lowest possible speed. Everyone should hear that, right? I have SSID in the air, so everyone should be able to connect. And here is the trouble. If you have an access point which is on that small table here, our 11AC access point 3825, this access point is able to do 11AC, which means 1.3 gigabits per second in the air. And if you connect, or if you are transmitting the beacons on 6 megabits only, or even on 1 megabit to have it more easy to calculate that, so instead of one frame, instead of one beacon running on 1 megabit, you can transmit 1,300 frames on the speed of 1.3 gigabit speed. So each SSID which you advertise in the air does consume something like 10 to 15% of the airspace bandwidth. Okay? And that's a technical thing which you cannot argue with that. That's a fact. Utilization on 1 megabit speed frames with 6 SSIDs in the air, that's here on the top, 25 or almost 26% of the traffic. If you look at 3 SSIDs, it's almost 13%. So there is a reason to not create a huge amount of SSIDs. Our approach is that you don't need to have 5 SSIDs. One for salespeople, one for network admins, one for the management, one for BlackBerries, one for barcode readers, one for guests. We don't need that. You can have single SSID codes, for example, production, and you can apply different quality of service, different speed, different priority, different rate limits, different VLANs, different access control lists, different filtering rules, based on that. Okay? So our approach is really something which we call flexible. Just imagine that we can, for different user, also assign different topology. So some users will be going bridge at controller. Some users will be bridge to access point to specific VLAN. And another user will go to different VLAN. Even more, we can do that per application. So some application will go to a specific VLAN. Another application will go to different VLAN. Do you know what I'm using here to display my screen? A tablet, of course, yeah. But application or protocol which is used. It's a Bonjour. It's a Bonjour protocol from Apple. There is the same protocol or different protocol from Android, from Google, to be able to share the screen over the Wi-Fi, over that. That's cool protocol. I can walk, I'm mobile. If I have 2 hands, I can also use the second hand instead of handling my microphone. This is something which is using multicast. So what we can do, we can contain the multicast traffic to a specific VLAN. For a multicast VLAN. I will talk about multicast a little bit later, but just think about that it makes sense to have application VLANs. So another feature which is really nice and helpful in the dense deployment or hyperdense deployment, the idea is quite simple. So you have a lot of access points. Why? Because you have a lot of people. And we do not play the game like our access point does have better coverage, like can do higher distance from the client. In hyperdense environment, it's not the case. In hyperdense environment, you have opposite issue. You will need to have a lot of access points in the same place and to limit the coverage to minimum, to create as less of noise for your neighboring access point. So access points are limited on the transmitting power. Access points are talking each other about the situation in the air. And I'm talking access point, not controller, okay? Just to be sure that you get it, because there is a competition who did that on the controller, this feature. So in our case, this feature, or all features which I will mention today, works even without controller, even if the controller is not available, okay? So the idea is simple. So if access point disappear for whatever reason, someone is an idiot and just cut the cable, okay? So if the access point disappear, another access points which are in that area will increase the transmitted power to cover those clients. It will not be optimal, but users will have signal, will have coverage, okay? You were talking, or Kirill was talking, and there was a discussion with IDS and wireless IDS, wireless IPS. So of course we can change the channel if we see the noise, if we see the interference. So for example, someone will go with Bluetooth and the signal or the noise will be so high that it is better to change the channel. We can do that. It helps in the dense environment. Sometimes you have a place where you don't have wire, where you don't have Ethernet connections. So sometimes you need to use mesh, self-healing, self-forming mesh. Sometimes you are in the environment which is, historical building. So you cannot place the access point or power and wire everywhere where you need. So if something happens, of course it will self-heal and self-react. Self-forming, self-healing mesh. No problem at all. Wireless inside or outside, indoor or outdoor, I don't care. Another feature is high availability in general. So first of all, which I said, is that we don't need controller to access point to operate. Our approach is that the access point is clever and intelligent enough to do all decisions. Access points are talking each other. Why we need a controller? To monitor and manage. If you have 1,000 of access points, that's not something that you would like to change the setting one by one. We are only humans, we will do mistakes, right? Even if you have scripts, those scripts will not work on 100%, not on the first try, maybe on the second if you tune it, okay? So we have a controller which is a monitoring and configuration tool. When I say this, what it means, we don't need the controller to be on site. We can have a controllers in the data center, somewhere on the planet, okay? So for example, Siemens is having controllers only in Germany. There is no single production wireless controller in Russia, in Czech Republic, in Poland, nowhere, just in Germany. Access points are everywhere, okay? We don't need the controller to be present to network to operate, okay? Another thing is, as we do not need the traffic to transfer through the controller, it makes sense that the controller can be virtualized. Okay? So the controller can be running on VMware, as the VMware is one of the partners here. The controller can be running on Microsoft Hyper-V, as Microsoft is the partner here. Okay? It can be fully virtualized in your data center, and access points can be all around the country. No problem at all. Performance and tuning. So, filtering, multicast at the access point. That's a very important feature. That's a very important feature, especially if you have devices like this, where, especially those which are made by Apple, they are for dumb users like me, okay? I cannot turn off the Bonjour protocol. The only thing which I can do is not use it. It's turned on by default, and my device, my Apple device, is sending 3 layer 2 multicast frames per second. Multicast, layer 2. Two bad things with Bonjour, okay? The first is layer 2, the second is multicast. So if I want to transfer my video stream or audio stream from my tablet to somewhere, to Apple TV, or to the screen, to the beamer, okay? It goes through the multicast on layer 2, which means I need to be on the same subnet by definition. It will not be routed, okay? Another thing is the multicast. Multicast is going on the slowest speed. So again, just think about the idea that multicast is going on the slowest speed, and I have 1.3 gigabit per second in the air, and I'm using 5 megabits, for example, for this stream. Okay? So, why filtering the traffic is important? If I am a student, which do not need to do a multicast, I can block it. Because if I block it on my access point, it will not need to go to the wire and to be transmitted on another access point. Okay? If I am a teacher, my multicast traffic will be allowed to be able to present, to be able to deliver the teaching, right? So filtering of the multicast traffic on the access point for a specific user is an important thing. We can do more. We can contain that traffic to specific VLAN. So now imagine the fact that I have 13,000 of clients in the network. Okay? I cannot have all in the same VLAN. I can, but okay, that's the next topic. But if it makes sense, I will not have it in the same VLAN. And I still can use multicast because that multicast traffic, which is layer 2, which is okay to not use IP addresses, will be handled correct way. Intelligent broadcast control. Broadcast is even worse than multicast. Again, going on the lowest speed, again, present everywhere, okay? So what we can do, access point is intelligent device, and access point can answer for ARP request, for example, in the name of the client. Okay? So instead of sending the ARP request to the client and transferring the ARP reply over the air, the access point will handle it for me. Okay? Access point, not a controller. Of course, controller can do that also, but if the controller is in US and we have the access point here, no need to utilize the VPN. Buffering and prioritization. So if you have devices like this device does have one issue. Battery is always not big enough, right? So this device or those type of devices are sharing or are saving the battery, saving the energy as much as they can. So these devices are going to sleep, for example, for 80 milliseconds. And then the access points need to buffer the data for that. And then when the device is, again, not sleeping, that data must be buffered. Okay? And that's the way how we share or we save the energy. We do that, no problem at all. Dynamic conversion of multicast and adaptable multicast transmit. There are another features from the technical point of view which helps. So instead of sending the multicast traffic on the lowest speed, we can send it on the lowest speed of connected client. So if I have all clients running on 300 megabits, I will not send it on 5 because I know that each client will understand it on 300. Distribution of clients. So definitely, this device is able to run on both 2.4 and 5 gigahertz radio. You have seen that already, that I was roaming from one access point to from one radio to another. 5 gigahertz radio is much better because we have more channels. Okay? So it makes sense if, and even more, the channels are not overlapping. So it makes sense if you do have a device which does support 5 gigahertz to force it to go to 5 gigahertz. So that's the first thing. The second thing is Murphy law. If something can go wrong, it will. Okay? It's everywhere on the world the same. So if you have 3 access points in this place, of course, all clients will be connected to one or two of them. So you have 2 access points which are overloaded, and you have one which is underloaded. So if another client will try to connect to overloaded access points are sharing this information together. Not with controller, access point, okay? Access point and the location are sharing the information, and they will distribute those clients automatically to load balance it. Another features. So there are features which are above the Wi-Fi. Features like API with localization. So you have already seen the fact that I was moving, and Kirill was also showing some screenshots regarding the user presence, where the user is. So one of those features we use at those stadiums. So we talk to the applications which are running over the network, and we share the information. So for example, if you are on the stadium and you use, and I will show that in a few seconds later, if you do open the application which is written for New England Patriots, for those fans, you can press the button, show me where are the nearest toilets. And because the application knows where you are, because the API is open and integration is done, it can navigate you. It can tell you that toilets nearby, there are 2 toilets nearby. One does have waiting time 1 minute and one is empty. So you can see the waiting times. So it is integrated. The API is available. You see how many clients are where. Where is the client? VLAN assignment. So just imagine that we have 13,000 of users or 17,000 of users connected to the same Wi-Fi, the same SSID, and we need to load balance them to VLANs. And we need those VLANs to be present on all and every access point if needed. So if I roam in the VLAN 10 to another access point, the VLAN 10 must be present there. I will not be able, it makes no sense, to change my VLAN while I roam. Because the video which I'm just watching with those fans playing the video for fans where the players are playing, will block if I change the IP address. It will not work well. So I need to stay there. Traffic engineering, multicast control, I mentioned it. ARP proxy, mention it. Policy, I mentioned it. Large subnets, I mentioned it also. Channel efficiency, rate control. We can do rate limit. You have seen that already. And we do that on the radio, on the access point, not at the control. It makes no sense. It should be offloaded to the access point. Rate limit, client load balancing, packet scheduling. So the idea is how we handle those buffers which we have on the access point. Radio frequency, like noise control, channel plan, dimensioning, and antenna. Regarding antenna, that's another really important story. If you play the game with outdoor, if you play the game with hyper-dense environment, you need to have a really flexible set of antennas to be able to focus your signal only to the place where you want to. Okay? So variety of antennas, it's definitely our benefit. It's more than just Wi-Fi. This is already a 2 years old slide from the first Super Bowl, which was delivered and maintained and monitored. So you can see that there was almost 15,000 clients. It's here, 14,751 clients. And the peak, there was over 9,000 clients. That's the bandwidth. And that was in US. So you can see that almost 11,000 of devices were Apple 2 years ago. Today, it's a little bit different. What was funny for me when I saw that on the first time, Windows Mobile, almost 50 users. Okay? So, 2 years ago, situation was completely different. We have those reports, everything available. Kirill was mentioning the purview. I was mentioning the purview, the business analytics. So it's not only about the Wi-Fi itself, but it is also about the analyzing what is happening in your network. So as I mentioned, over 17,000 clients connected in the peak to the Wi-Fi. Over 6 terabytes of data transferred over the Super Bowl game. Okay? Here is the total application usage as a function of the time. So you can see that the halftime was the peak and at the first quarter. US is different based on the IDC, which we saw in the morning. Apple, based on the IDC, you have seen 29%. Here it is 82%. US, definitely different. But look at that, and that's something which I like. 10% of Wi-Fi bandwidth during the game was consumed by software upgrades. Nice, right? So the stadium, the NFL, is providing the Wi-Fi for fans to chat over the Facebook, okay? To post the pictures, to have user experience. And 10% of devices are doing firmware upgrade. Cool. Social networking, number 1. Okay, so if I read it well, 15,000 Wi-Fi connected fans were using social media. Social network, of course, Facebook. The second is Twitter. Next one is Instagram. And the last one is something which I have not seen at all, Snapchat. Social network based on the bandwidth. During the time, application response time. So you can see what is the user experience for those applications. So you can see that Facebook was quite okay, Twitter even better, but Instagram was quite bad. So you can try to tune it if you have chance. This is something which we can provide not only for internet access, but for the data center also. That's the purview. Okay? Background applications. So cloud storage took 35% of the traffic at the Super Bowl, at the game. It's not only about the Wi-Fi, okay? It's about more, it's about the user experience. It makes no sense to build a Wi-Fi for users only to be able to read the news. It makes sense to make the user experience nice. So in general, our solution consists of access points, controllers for the management, and the software above that. So access points are mandatory. You will not have our wireless without our access points. That's obvious, right? Controllers are something which you use for configuring and monitoring. And management is something which you may use, if you wish, for the software above that. So 3825 is our access point, which you can see here. That's 11 AC access point. Kirill was mentioning 90,000 packets per second, 2 Ethernet ports, 1.775 gigabits per second of the speed. 2 Ethernet ports. You cannot transmit 1.7 gigabits over 1 gigabit port. Okay? The second small one, much smaller. We have 11N access points only. If you don't like 11 AC, if you don't need, there's no reason to not need that because the price is the same. Outdoor access points. Controllers. As I mentioned, we have physical controllers and we have virtual. You can run it on Hyper-V, you can run it on on VMware, and you can have really big controllers. No problem at all. Thank you for your time.